Hello there and welcome back to the Science Sleepy Minds. The stars barely flicker as you glide past them, tucked safely inside a sleek humming spacecraft that's barely aging with you inside. Outside, time moves like a freight train, but in here, everything feels suspended, as if someone pressed pause. The Earth you left behind, it's still spinning, people rushing, living, aging, but not you. You're moving fast. Fast enough that reality itself starts to warp a little. Fast enough that when you finally return, the people you knew will have lived entire lifetimes. Or maybe they won't be there at all. You're not just travelling through space anymore, you're travelling through time. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, I'd love to know where you're watching from and what time it is there. Drop your location and your local time in the comments. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're lying back in a padded recliner, heart rate steady, muscles weightless. The engines are silent now. You've escaped Earth's pull, and you're coasting through deep space, far faster than anything should reasonably be able to move, at least according to your gut. But physics has other plans. The first thing to go is your sense of time, not in a dramatic way. No whooshing clocks or magical sparkles, just things start to drift. You nap for 20 minutes, but your onboard system says an hour passed. You send a video to Earth and receive a reply before you expected it. Your body feels fine, but the calendar keeps betraying you. Welcome to time dilation. Here's the terrifyingly cool part. The faster you move, especially when approaching light speed, the slower time passes for you compared to everyone who stayed still. It's not science fiction. It's called special relativity, and it's been experimentally confirmed using atomic clocks, satellites, and yes, astronauts. Right now, you're travelling at 90% the speed of light. That means every day for you stretches into maybe 2 days, 3 days. Back on Earth, it adds up fast. The seconds feel normal. You aren't stuck in slow-mo, but to those watching you from home, it's like you're drifting forward in slow motion, your time crawling while theirs runs. This isn't just about moving fast. It's about reality itself reshaping based on your motion. Einstein tossed that into the public sphere in 1905, with the casual flair of someone explaining why your milk goes sour. His theory of special relativity included one crucial idea. Time and space are part of the same fabric, space-time, and it bends, stretches, and twists under certain conditions. One of those is speed, the other, gravity. But we'll get to that later. Historians still argue whether Einstein truly grasped the psychological consequences of his theory, or if he was just trying to win a bet with Newton's ghost. Regardless, the math checks out, and here you are, drifting along, feeling timeless and vaguely annoyed that your snacks expired while your body didn't. Fun fact, on the International Space Station, astronauts experience a teeny tiny bit of time dilation. After 6 months in orbit, they're about 0.005 seconds younger than their Earthbound twin. Not exactly a leap into the future, but the principle is the same. Crank that velocity up and the differences get weird. Let's say your ship hits 99.9% the speed of light, because you're dramatic and like a challenge. Now, for every 1 year you experience, about 22 years pass on Earth. That means a quick 3-year trip for you could span over 6 decades down there, and you thought returning from vacation with unread emails was bad. Here's where things start to itch. You feel normal. No stretched minutes, no visible slowdowns. Your ship's digital assistant still chirps awake every morning. You brush your teeth, float awkwardly into your flight suit, sip space coffee from a pouch. Time behaves the way it always has, for you. But Earth has aged. People have changed. Governments fell and rose, languages drifted, new slang emerged, and that show you were binge-watching? Yeah, it got rebooted 3 times while you were gone. Meanwhile, let's pause to appreciate a lesser-known historical tidbit. In 1971, scientists flew 4 cesium beam atomic clocks around the world on commercial airliners. When compared to stationary clocks back on Earth, the airborne ones had experienced less time. Tiny, but measurable. That's right, you can time travel by flying coach, though the peanuts probably aren't worth it. The bigger your speed, the stronger the effect. But what does it feel like? Mostly eerie. You don't notice the dilation until you see the consequences. Your messages arrive late. The Earth's reply videos start looking older. You watch hairstyles go from buzz cuts to cyberpunk green mohawks. You start missing references. Someone sends you a meme and you have to Google 5 words just to understand the joke. And then comes the unsettling thought, maybe you're the one who's outdated now. Quirky side note. Some theoretical physicists joke that if we ever master near light speed travel, our spacecraft manuals will need constant updating just to keep up with Earth's evolving language. Imagine trying to decode slang from 2400 AD just to start the engine. Back in your cabin, you stare at a photo of someone from Earth, a loved one, maybe a sibling, a partner, a pet. You wonder if they're still alive. You wonder if they'll even recognize you if they are, or if they'll think you abandoned them, aging decades while you stayed frozen in your metal cocoon. Historians still debate whether the psychological cost of time travel was ever seriously considered in early sci-fi. Writers loved the science, but rarely stopped to ask what it means to watch the world move on without you, kind of like logging back into an old social media account and realizing everyone else has moved on, but with 80 years of birthday parties you missed. As your ship continues, you make a habit of recording logs, not because anyone will hear them, but because it grounds you. Day 143. Earth time. Who even knows? You muse about the weather you can't feel, the cities you can't walk through, the people you're slowly becoming alien to. But hey, look on the bright side. You're barely aging, your skin's great. You're technically in the future, just alone. You float past a nebula that won't exist in another few million years, a cosmic cloud glowing like a jellyfish in ultraviolet hues. No traffic, no noise, just you, your ship, and time stretching around you like a soft invisible fabric. And this is only the beginning, Einstein's nap-worthy breakthrough. You stretch your legs in 0G, drifting toward the circular window like a bored astronaut in a sci-fi daydream. Outside, the stars are still smeared across the sky like spilled glitter, but something nags at you, the sheer weirdness of it all. Time isn't behaving, not like it should. And this, you're told, is Einstein's fault, not in a malicious way. He didn't break time on purpose, he just noticed it was already broken, or at least flexible, and then he told everyone. Relativity is one of those elegant, headache-inducing concepts that makes perfect sense once you've chewed on it for a few decades. Before Einstein's 1905 special theory of relativity, people had a pretty straightforward relationship with time. It ticked forward. Same for everyone. Maybe you felt like Mondays lasted longer, but that was just your job, not physics. Sir Isaac Newton, bless his powdered wig, thought of time as absolute, uniform, a cosmic clock ticking away, indifferent to anything else. But young Albert, then a patent clerk in Switzerland with too many thoughts and probably not enough sleep, decided that wasn't the whole picture. He imagined riding alongside a beam of light, moving at the same speed as it, and then he asked a question nobody else had. What would the light look like if you were moving next to it? Turns out, it's not about the light changing, it's you who changes. Your time, your space, your perception. Everything warps so that the speed of light stays constant for everyone, everywhere, always. That was the key. The entire universe bends over backward to protect that cosmic speed limit. So if you move faster, really faster, time slows down for you to keep things consistent. That's time dilation. This wasn't just a fun thought experiment. It cracked open the entire structure of the universe. Time and space weren't separate anymore. They were fused into one entity, space-time, a four-dimensional fabric where everything, planets, stars, your drifting ship, sits and moves. You're not just travelling through space, you're moving through this warped elastic grid that responds to mass and motion, like a trampoline under a bowling ball. Right now, your ship's ridiculous velocity is bending space-time just enough to mess with your internal clock. Not painfully, not even noticeably, but mathematically, irrefutably, you're living in a slightly different tempo than everyone else. Quirky side fact, Einstein didn't actually call it time dilation. That term came later, from physicists who had to explain it to students without causing mass panic. One even joked in a lecture that time dilation feels a bit like jet lag with existential consequences. And if all this makes your head spin, good, you're not alone. Even Einstein's peers needed years to digest the implications. Historians still argue whether the 1905 publication of his paper was fully understood at the time or just politely nodded at by physicists too embarrassed to admit they were lost. You float back to your ship's console, tapping through the nav log. Every second you're here, Earth is sprinting ahead in the race. You've got the nap advantage, hibernating through the centuries without closing your eyes. It's the strangest kind of time travel. No flash, no time machine, no phone booth, just speed. And here's the beautiful paradox. The faster you go, the less time you experience. Yet to you, it feels like everything's working fine. Einstein's equations don't say you notice the slowdown. They just say it's there. You're aging slower, but you'd never know it without an outside reference. That's the kicker. Relativity is all about reference frames. Imagine two ships, yours and one back near Earth. You're zooming, they're chilling. You each believe you're stationary and the other is moving. You're both technically right. In your own frame of reference, your time feels normal. But compared to them, yours is dragging. This concept rattles philosophers almost as much as physicists. If time depends on where you're standing or flying, then what even is reality? Is there a true now, a single, universal moment? Spoiler. Most physicists say, nope. There's no absolute present, just overlapping slices of time smeared like cosmic marmalade across space-time. Delicious, but disorienting. You kick off the wall and hover toward the galley, wondering if you can microwave freeze-dried lasagna at near light speed. Answer: yes, but the manual was written a century ago. The language is a little weird, and the nutritional facts list vitamin Zeta. Out in the cosmos, other celestial objects are doing their own relativistic dances. Pulsars spin so fast that their rotational time dilation is measurable. GPS satellites, those handy orbital guides, have to account for both gravitational and velocity-based time shifts. Without constant relativistic corrections, your phone would put you in the wrong city. Here's something fringe you may not have heard. Some researchers have hypothesized that ancient myths about gods moving slowly or appearing ageless might have been early interpretations of time perception differences, tribes trying to explain what seemed like beings who experienced time differently. Wild? Sure, but not impossible. You glance out again at the stars, there's no way to tell that time is passing differently for you. There's no sensation, no nausea, just the gentle hum of your ship and a creeping awareness that you're gradually peeling away from the rhythm of the human world. Back in Einstein's day, trains were the fastest thing around. He used them as analogies to explain time dilation. Today we have jets and orbital modules. Tomorrow maybe near-light speed ships like yours. But the rules stay the same. And one more thing, this isn't science fiction anymore. We've measured time dilation, proven it. Your wristwatch, if synced with Earth's and flown on a fast enough jet, will tick differently. You don't need wormholes or flux capacitors, just speed and patience. A final cheeky detail. Einstein never won the Nobel Prize for Relativity. Nope. They gave it to him for explaining the photoelectric effect. Historians still debate whether the committee was just overwhelmed by the implications of relativity or too afraid of upending their entire worldview before dessert. So here you are, a few decades or centuries, out from launch, depending on who's counting. Floating, thinking, and slowly becoming an echo of a time that moved faster than you ever could. And yet somehow, you're still right on time. What even is time though? You stare at the ship's interface long enough that the numbers blur into meaningless shapes. Earth years, ship years, mission duration, speed relative to the speed of light. All very official, all very quantifiable. But something nags at you. Beneath all the math and the blinking lights and the carbon-filtered air, what is time? You feel it, sure. Seconds ticking past. You've measured it since you were a kid. School bells, microwave beeps, overdue notices. But none of those are time. They're just reminders that time is doing its thing. And here you are, flung halfway across the galaxy, wondering if time's still even real, if it isn't behaving like it used to. Let's start with the basics. Time, as you know it, is the measurement of change. Things move, things decay, ice melts, suns burn, people age. If nothing ever changed, time wouldn't mean anything. You wouldn't be in a moment, you'd just be. Time is the ruler you use to describe motion and progression, but it's not the movement itself. Back on Earth, time is tightly choreographed. You follow atomic clocks, use them to tell when to eat lunch or attend funerals, but out here, the notion becomes a bit slippery. You're not synced with anyone anymore. You're moving so fast that your now doesn't match anyone else's. So which one is the real time? Some philosophers, ancient and modern, would argue none of them. The ancient Greeks were already in on this debate. Heraclitus famously said you can't step into the same river twice because everything is in flux. Time, to him, was change itself. Meanwhile, Parmenides argued that time was an illusion and that all change was illusory. His logic: if the universe is eternal, then everything just is. Nothing truly begins or ends. Your journey, this ship, the blue marble you left behind, it's all part of a single unchanging whole. Philosophy aside, modern physics takes a somewhat middle path. Time exists as part of space-time, a measurable dimension, but it's not universal. It bends. It's personal. Like a grumpy roommate, it behaves differently depending on how fast you move or how close you are to something massive. Right now, time for you is not what time is for someone on Earth, and they might as well be talking to a ghost when they try to reach you. Your present isn't the same as theirs. In fact, from your perspective, they're aging rapidly, sprinting through decades like a Netflix series set to 10 times speed. From their perspective, you're the one frozen in time, barely blinking. Here's the kicker. Both views are correct. That's the beauty and horror of relativity. There's a popular analogy physicists use, the block universe. Imagine space-time as a giant frozen loaf of bread. Every moment that has ever happened or ever will happen is already baked in. You're just a little slice moving through it, unaware of the slices ahead or behind. Past, present, and future all exist simultaneously. You're just experiencing them in order, like a Netflix show you can't skip ahead in. Unless you're on this ship, of course, in which case time's pacing gets weird and the plot changes halfway through the season. Historians still argue whether Einstein ever truly bought into the block universe interpretation. Some say he did, especially later in life, after the death of his close friend Michel Besso. In a letter, Einstein wrote that, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. Others think he was just being poetic, not literal. Either way, comforting or creepy, it's a theory that lingers. As you float through this frozen moment of starry silence, the concept settles on your shoulders like a weighted blanket. Maybe every moment you've ever lived still exists somewhere, etched into space-time. Your 4th grade birthday party, the first time you kissed someone, the last time you saw Earth's sky, all still there, hidden behind the veil of perception. You just can't visit them. Unless... well, no. We'll get to time travel backward later. Spoiler, the math hates it. A quirky thought. Some fringe theories claim time might be granular, made of indivisible chronons, the way matter is made of atoms. Tiny, indivisible packets of time that tick like a cosmic metronome. So instead of flowing smoothly like syrup, time might be more like a flipbook. Quick static frames that give the illusion of motion. No one's proven this, but the idea's out there, floating in the odd corners of theoretical physics and Reddit forums. Back to you though. Right now, you're in motion, and therefore, your experience of time is skewed. You're surfing through space-time in a way that almost lets you cheat death, aging a little, while others age a lot. From a biological perspective, you're extending your life. From a psychological one, you're becoming more and more unmoored from the world you knew. What's more disorienting is the idea that there's no single clock in the universe ticking away true time. Every particle, every ship, every galaxy has its own rhythm. There is no master timekeeper. The cosmos doesn't care what hour it is. It doesn't even agree that hours exist. There's something both deeply freeing and deeply lonely in that realization. You glide past a distant sun, a red dwarf wobbling gently with the mass of a nearby exoplanet. The star has existed for billions of years, will go on existing for billions more. But how it experiences time, or rather how we observe it doing so, depends entirely on our motion relative to it. To that star, you're the one flickering like a firefly, here for a blink, gone. You check your ship's calendar. Earth time says 204 years have passed since launch. Onboard time? About 6. You haven't even finished your boxed wine supply. That's the gift and curse of time dilation. You get a front row seat to the slow unravelling of the future. You're living on fast forward, but only in the eyes of others. In here, Your heartbeat still ticks. Your dreams still make no sense. You still lose socks in the dryer. So, what is time? It's not a river. It's not a line. It's not even a ticking clock, and it's the weird elastic scaffolding of your entire reality. And you're skating across it like a kid with no brakes. How clocks lie on rockets. You wake to the faint hiss of life support and the soft glow of the onboard systems gently pulsing in the dark. For a moment, you feel like you could be anywhere. Coasting in your bed back on Earth maybe, under the dull hum of a ceiling fan. But then you look outside, stars everywhere, silent and indifferent. No blue sky, no traffic noise, just you, your ship, and the unstoppable ticking of space-time, though how it ticks is up for debate. You glance at the mission timer, then you glance at your wristwatch. A few moments of harmless blinking, frowning. One of them is wrong, or maybe they both are. The digital readout on the ship tells you that Earth has gone and aged a little more than you have since you started napping. Not by much yet, but it's happening. You're starting to drift away from Earth's sense of now. Back on Earth, when two people argue over what time it is, it's usually just someone forgetting to adjust for daylight savings. But out here, the clocks can all be right and still disagree. That's relativity for you. It doesn't just mess with your speed, it messes with your whole idea of reality, including the ticking of timepieces. In the early 20th century, physicist Hendrik Lorentz was already working on equations that hinted something weird would happen to clocks moving near light speed. But it took Einstein to say, actually, your whole sense of time might be relative, and mean it literally. Here's a practical thought. Imagine you have two identical clocks. You sync them perfectly. One stays on Earth, the other hops into a spacecraft and zips around the planet at near light speed for a while. When the astronaut returns, the clock on the ship shows less time has passed. The faster it travelled, the bigger the difference. This isn't just theory. In 1975, scientists launched super-precise cesium clocks on fast military planes, and the airborne clocks returned slightly behind their Earthbound twins. A few billionths of a second, sure, but measurable. Atomic clocks are petty like that. Your spacecraft, flying far faster than those planes, exaggerates the effect. Your internal clock, both mechanical and biological, is ticking slower compared to Earth's. You don't feel slower, though. Your thoughts still flow at the same pace. You still brush your teeth, drink your weirdly metallic-tasting water, and pretend you're doing fine. Here's where it gets squishy. Your motion, relative to Earth, slows your passage through time from Earth's perspective. But to you, it's Earth that's speeding up. If you were feeling feisty and wanted to argue, you could say they are the ones whose clocks are lying. After all, from your view, you're still. They're the ones zipping away behind you. It's all about frames of reference. Relativity doesn't care who feels like they're moving. There's no privileged viewpoint. Just perspectives. Shifting truths. Two clocks, both sure they're right. Like a cosmic version of your parents disagreeing about what time the movie starts. Let's make it weirder. Imagine you and a friend both launch on identical rockets in opposite directions at near light speed, then come back to Earth. Whose clock is slower? That depends on acceleration. See, special relativity only works cleanly when both observers are in inertial motion. No speeding up, no slowing down. But if someone has to turn around or stop, that introduces acceleration, and that breaks the symmetry. Historians still debate who first realized that acceleration could be the tiebreaker in the twin paradox. The thought experiment where one twin goes to space and comes back younger. It's easy to forget how controversial that scenario was. Some early physicists thought it violated common sense. And they were right. It does. That's the point. A quirky side note. In 1960, physicist Herbert Ives tried to prove time dilation was nonsense by designing an experiment to debunk it, and accidentally confirmed it instead. Nothing like having your own experiment betray your thesis. You float down the corridor of your ship, one hand trailing the smooth metal wall, and try to imagine what's happening on Earth. Are they still checking clocks the old-fashioned way? Or have they just given up and started using whatever's trending on their neural implants? The Earth-based timestamp on your messages shows more time than you expect. You reply to a ping from Mission Control and receive a response dated 4 months later. You blink. You didn't feel those months. You didn't live them, but they happened. For them. And here's where it starts to sting. Say you have a daughter back home. You left when she was 10. You plan to return in, say, 10 years by your ship's clock. But when you land, she's already in her 90s, or gone. You've skipped her entire life, not by choice, but by physics. Your clocks lied to each other in a way that neither of you can fix. Now imagine two more clocks, one deep in a gravity well, like on a massive planet, and one far away in low gravity. Even stationary, these clocks tick at different rates. General relativity, Einstein's 1915 sequel to his special theory, says gravity bends space-time too. The deeper you are in a gravity field, the slower time moves. A clock near a black hole, it practically freezes. We'll talk about those time-warping monsters soon. For now, just remember, velocity isn't the only way clocks lie. Mass does it too. GPS satellites have to correct for both effects. They're high up, less gravity, and moving fast. If we didn't adjust their clocks, your location would be off by kilometers, every day. So next time your phone gets you to the coffee shop on time, you can thank relativity. Or curse it when it tells you to turn into a lake. You check your logs again. Every timestamp has two columns, ship time and earth time. One is tidy. The other is starting to look like a fast-forwarded documentary. Whole cities have risen and fallen since you left orbit. And your coffee hasn't even cooled yet. It's easy to laugh at the weirdness. Until you realize those people aging on Earth, they're real. They're your people. And they're living at a pace you can't match anymore. You grip the railing and watch the stars drift, wondering not when you are, but whether anyone else could possibly agree with your answer. Living fast, aging slow, you float again. You're getting good at this. Just enough push off the bulkhead to drift gracefully through the air. No spins, no panicked flailing. It's your ship now, your pace, your time, which is, inconveniently, not anyone else's time. Outside, the stars feel like slow-burning candles. Inside, your body hums along in its usual rhythm. Heart beating, cells dividing, the occasional yawn stretching across your face. But according to Earth, you should be older than you feel. Or rather, you should feel older. But you don't. That's because you're living fast and aging slow. Not metaphorically, not I still feel 25 inside slow. No, literally slower. This is time dilation in full effect, and you are its living, breathing, oddly fresh-faced example. The most famous example of this bizarre phenomenon comes from a pair of twins, one of whom blasts off into space at near light speed, while the other stays put on Earth. It's called the twin paradox, and yes, it is kind of unfair if you're the Earth twin. When the spacefaring sibling returns, they've barely aged, maybe a few years. The Earthbound twin? Wrinkled, grey, and possibly baffled by whatever emoji language humans are using in the future. This isn't just science fiction or a physics riddle. It actually happened in a mild form with the Kelly twins, Mark and Scott, NASA astronauts and identical twins. In 2015, Scott spent 340 days aboard the International Space Station while Mark stayed on Earth. When Scott returned, he had experienced a tiny fraction of a second less than his brother. Measurable, confirmed. He was, by the math, slightly younger. Now take that same idea and crank the speed up. You, here on this ship, are living proof of the effect scaled to the extreme. You could leave on a high-speed interstellar trip and come back to find entire generations past. Maybe even your great-grandchildren waiting for you. Older than you are. Which is unsettling, yes, but also kind of metal. The faster you go, the more pronounced the effect. At 99.999% the speed of light, time dilates so much that a trip lasting 10 years for you could equal thousands of years on Earth. Think about that. You sleep, eat, float, sip vacuum-sealed tea, and when you come back, humanity might have built cities on Saturn's moons, or accidentally uploaded everyone into sentient yogurt. Who knows? Historians still argue whether ancient mythologies, like gods descending from the heavens after mere moments, only to find the mortal world changed, were subconscious attempts to describe time dilation, or just poetic metaphors for loss. Either way, the echoes are there. Mortals age, the gods do not. Sound familiar? From a biological standpoint, your cells keep ticking at their normal pace. Your telomeres, those tiny little caps on the ends of your DNA, still shorten. Your bones still stretch and shrink and complain in low gravity. But all of that is happening while relative time passes much faster elsewhere. You're aging, just not in sync with the rest of humanity, which is both a scientific triumph and an emotional nightmare. You record a log. Day 801, ship time, thinking about my sister. She'd be in her 60s now. You pause, you think. I still hear her voice the same way. I can't imagine her older. I wonder if she'd recognize mine. It's not that time is cheating you. It's just playing by different rules. Here's a fringe tidbit to chew on while you sip your lab-brewed chamomile. There's a hypothesis that high-speed space travel might preserve consciousness in a way, that by slowing time you reduce the rate at which your brain experiences entropy. Some have even proposed using time dilation as a kind of longevity escape hatch, launching humans into fast-moving orbits as a form of suspended animation. Just a few problems, like loneliness, also the cost, and cosmic radiation. But sure, call it relativistic retirement. You float by the med bay and check your vitals, heart rate, normal, muscle loss, stabilised thanks to those magnetically resisted resistance bands that feel suspiciously like medieval torture devices, but your skin, barely a wrinkle, your memories, crisp. Meanwhile, Earth is galloping ahead. You check the mission archive. The latest batch of messages include photos, buildings you don't recognise, political slogans you can't translate, fashion that appears to involve a lot of chrome, and extremely dramatic eyebrows. You chuckle, then you frown. A new report, your hometown has been renamed. Again. This is what happens when you outpace history. Here's another fun fact. Time dilation is a two-edged sword. You might be younger physically, but emotionally, you're being stretched in the other direction. You're carrying memory fragments of a slower world, a world that's now archived, pixelated, partially forgotten. You're a museum of now-antique thoughts, floating in a future that never paused to wait for you. That's the paradox of relativistic life. You can move through time without experiencing it. You can live fast and still miss everything. A cheeky aside, in the 1980s, a popular sci-fi cartoon featured characters who travelled at high speed between galaxies, but conveniently aged normally. The physics? Trash. But the hairstyles? Iconic. You pull out a small tattered book you packed for comfort, a poetry collection. Words from centuries ago now, even though you read them last week. Somehow, they feel closer than the newest message from Earth. Maybe because they exist outside the timeline you're watching speed away. Maybe because they don't age the way people do. You read a line aloud. It echoes strangely in your chamber. Time is the fire in which we burn. You smile. It's less threatening when you're barely smouldering. In a sense, your velocity is a time cloak. You've slipped behind the curtain, dodged the erosion that claims everyone else. But the cost? Disconnection. You're not of their time anymore. You're adjacent, like a childhood friend who moved away and never came back. Still you, just no longer part of the rhythm. You check your ship clock again. 10 Earth years since launch. Only 3 for you. 3 years of stillness, of watching the universe crawl past, of recording your thoughts, knowing they'll age faster than you do. And soon, it'll be time to decide. Do you turn around? Return to a world that's aged beyond recognition? Or do you keep drifting forward into time's slow stream, letting the future bloom without you? Your first million-mile hour. There's a point, just past absurd but not yet impossible, when your speed begins to peel reality away like cheap wallpaper. That's where you are now. Your ship hums along at something like 99.999% the speed of light. You're travelling so fast that you're putting in more than 1 million miles every single hour. You'd think you'd feel that in your bones, or at least in your stomach. But space is smooth, and your ship is built for this. No rattle, no wind, no screaming metal, just the deep, strange silence of speed. Everything feels calm, but everything is not calm. Because outside the window, the universe is starting to smear. Light itself doesn't behave the way it used to. Stars ahead of you shift into bluish pinpoints, shorter wavelengths, more energy. Behind you, they fade red and vanish altogether. This is the Doppler effect, but for light. The same phenomenon that makes a siren change pitch as it drives past is now changing the entire colour of the cosmos for you. Ahead, blues and whites. Behind, reds and emptiness. You're moving fast enough to stretch and squish the very fabric of the light waves around you. Fast enough that starlight ahead of you begins to push toward invisible wavelengths. X-rays, gamma rays. This is called relativistic beaming, and it makes your ship's view look like a tunnel of starlight narrowing in front of you, like you're plunging into the eye of the galaxy itself. A cheeky thought. You're moving fast enough that if someone took a photo of your ship from Earth right now, it would look shorter. Compressed in the direction of travel. That's length contraction, And yes, your ship is technically squished like a high-speed pancake, but only from the outside observer's perspective. Inside, everything feels normal. You're not stepping on your own toes or scraping your head on the ceiling. Relativity, remember, is always about who's watching. Historians still debate whether Lawrence ever truly believed this idea, or if he just came up with the math and hoped someone else would figure out the implications. Einstein picked it up and said, "No, this is how the universe actually works. Not metaphorically, literally. You move faster, space contracts, time slows, light warps, physics gets fun. Of course, this isn't something your body picks up on. There's no fast feeling. You're not windburned or smushed into your seat. Velocity, when steady, is a ghost, completely invisible to your senses. The only clue that you're screaming across space-time at an impossible speed is what's happening to everything else. Message delays grow longer. The light from distant stars behaves strangely. You check your reflection in a mirror and still look 30, even though Earth has added 80 years to its historical record. Your ship's systems have long since given up trying to translate new Earth file formats. The last update from home included a warning: may not be compatible with this century's software. Quirky side note: some physicists have speculated that at extreme velocities, certain high-energy particles in space could pose unexpected dangers, because your ship is ploughing into them so fast they hit like microscopic bullets. That's why your ship's nose is layered with what the engineers call dumb-thick shielding. Technical term. Still, despite the risks, you feel serene. You're moving faster than any human before you, faster than sound, faster than orbital satellites, faster than thought can travel in most brains before coffee, and you don't feel it at all, except for one thing: isolation. At this speed, connection becomes philosophical. You're not just far from Earth in terms of distance, you're becoming emotionally, culturally, temporally disconnected. You try to send a message, but by the time it reaches home, the recipient might be old, or gone, or digital, or worse, busy. So you record logs instead. Small moments, thoughts about the colour of starlight or the weird way the ship's tea always smells like dill pickles. It helps. But you're aware that time is building up like snow behind you. Every hour at this speed, Earth moves a little further into the future. Every minute you feel is another month for someone down there, maybe more. You do the math, just to torture yourself. 1 hour here equals 7 years there. You start thinking in conversions like a weird interstellar tourist. Happy hour for me, apocalypse season for them. Lunchtime for me, grandchild's lifetime for them. You laugh, then you stop laughing. Let's talk about your field of view. At these speeds, space seems to warp. The stars aren't just changing colour, they're clustering toward your front-facing direction. This is called aberration, not in a scary horror movie sense. It just means that thanks to your velocity, the light from stars that were originally to your left, right, even slightly behind, are all getting dragged into your forward vision. It's like tunnel vision, but cosmic. You're heading into a cone of light. The universe is bowing toward your motion. Fun fringe fact: if you were going exactly the speed of light, don't worry, you can't, you'd see all of space crushed into an infinitely bright point in front of you. But since that's physically impossible for anything with mass, including your overachieving ship, you just get the light show version. You pass a planetary system. By the time you even see it, it's already a relic. The light took thousands of years to get to you, and you're already moving so fast that it's Dopplered into hard-to-read energy. You lock it anyway, a flicker, a maybe, a star once known to someone. This is how the future feels, long, silent and fast. A reminder. The universe doesn't care how quickly you want to move. There's a speed limit and you're dancing dangerously close to it. You can't reach the speed of a light. It would take infinite energy, but you can sidle right up next to it, like someone tapping a sleeping bear. At your current pace, even small increases in speed require huge amounts of energy. Historians still argue whether the original design for ships like yours, capable of sustaining this kind of velocity, was more inspired by fusion dreams or sci-fi hubris. Either way, they made it happen. The ship works, you're still here. But Earth? You're not even sure it still calls itself Earth. You scroll through old photos, a mountain range, a dog on a beach, a vending machine that accepted physical coins, all obsolete now probably. You're a souvenir from a time no longer relevant, a biological time capsule, and you're just getting started. Eventually your ship's systems ping a reminder. You've got a course correction ahead. You stretch your arms, blink a few times, and reach for the controls, laughing at how slow your own movements feel in a ship travelling 186,000 miles per second. The irony of relativity? The faster you go, the less you feel it. But time knows. Time always knows. A very slow dinner on Proxima B. You're sitting in your ship's dining pod, staring at a tray of perfectly rehydrated lasagna that's steaming with all the artificial charm of a microwave ad from the late 2000s. It smells vaguely of cardboard and oregano, maybe a hint of disappointment. You take a slow bite, then glance out the window as if expecting someone to join you. They won't, because you're roughly 4 light years away from Earth now, in orbit around Proxima Centauri b, the closest potentially habitable exoplanet to Earth. Well, habitable is generous. It might have liquid water, sure, but it also has a red dwarf star that throws temper tantrums in the form of deadly solar flares. Think of it as Earth's angry, dim cousin with poor impulse control. Still, it's the kind of place humanity once dreamed of reaching. And now, here you are, hovering over its rocky terrain like a time-displaced tourist. Except your arrival isn't a big deal. Not anymore. Too much time has passed for this to be a moment of triumph. Back on Earth, decades, or centuries, have unfurled. You've only lived through a few years, maybe a dozen at most thanks to your ludicrously fast journey. But Earth moved on. You sip some synthesized wine, which tastes like disappointment in a test tube, and wonder who they are now. The humans. What they look like. What they care about. If they even remember the mission you were part of. You were supposed to be a pioneer, a face on a banner, maybe a paragraph in a textbook. But now, your ship's name might not even trigger a search result in their digital archives. Time dilation didn't just preserve your youth, it preserved your irrelevance. You turn back to the planet. Proxima b rotates lazily, its reddish surface occasionally catching glints of its parent star. It's tidally locked, always showing the same face to the star, which means one side's a scorching desert and the other an icy night. In between lies the Terminator Zone, the perpetual twilight band where temperatures might be stable enough for life. Scientists back in your century hypothesized about microbial life living in that narrow eternal dusk. Tiny things clinging to rocks, maybe tucked into shallow oceans. Nothing with poetry, nothing that would greet you. And yet, something pulls at you when you look at that dusky strip. It's alive in the way only untouched places can be. Old, unimpressed by your fancy spacecraft and improbable journey. You log the arrival anyway. It's what you were trained to do. Mission entry, orbit achieved. Proxima b present. No contact, no reception. Dinner, lukewarm. You send a signal back to Earth because that's what protocol demands. It'll take years to get there. More by the time anyone sees it, if anyone's still there to see it. You don't bother checking for a reply. The reply might outlive you. Here's where the loneliness starts to stretch in ways you didn't anticipate. It's not just being far away, it's being out of sync. You and Earth don't even agree on what now is anymore, and because of that, communication becomes a ghost story. You're talking to the past. They're answering from a future you'll never quite reach. Historians still argue whether interstellar exploration should have been undertaken by humans at all, or if it should have been left entirely to AI. Machines don't get emotional when their home planet forgets their name. Machines don't lose sleep wondering whether dinner conversations still exist. But you're a soft, vulnerable time traveller with questions that no onboard system can answer. Let's go fringe for a moment. There's a theory, more poetic than proven, that consciousness itself might be affected by time dilation. That your very experience of thought could slow or stretch, not in a way you'd notice, but in the way that 1 second of awe during a sunset seems to last forever. What if travelling this way, moving so close to light speed, rewires how you perceive now? What if your thoughts are being quietly sculpted by the tempo of the universe? You take another bite of lasagna, still cardboard, still tragic. You think about exploring the surface, but why? There's no one to meet, no flag to plant. The planet doesn't need your footprint. It's existed for billions of years without your commentary, so instead, you observe. The red light filters through your ship's canopy, staining your face in soft, dusky tones. Somewhere below, winds are howling across frozen basalt. Maybe something is stirring under the ice, or maybe it's a planet full of potential that no one will ever realize. You consider naming a mountain range. You don't. What's the point of claiming something that won't even remember you were here? Another fun tidbit. It's possible Proxima b has no magnetic field. That means any atmosphere it once had might have been stripped away by solar radiation. If you stepped out unprotected, you'd be flash-fried by ultraviolet tantrums. So, yeah, maybe stay in the ship. You imagine what it would feel like to host a dinner party here. Invite a few astronauts from different centuries, one from the early 20-teens, pale and cautious, one from the far future, eyes glittering with posthum and tech, and you, stuck between them, a relic and a pioneer, trying to remember which fork to use with rehydrated salad. Would they laugh at your slang? Would you understand theirs? Would they even eat? Another ship zips by in your imagination. Sleeker, smarter, a generation ship maybe, full of people born in transit, not even aware of what Earth used to be. You wonder if they'll stop by this world, if they'll wave to your lonely orbiting tin can, or if they'll just mark your mission logs as outdated and move on. You're not sad exactly, but you are stretched thin. That's the curse of arriving in the future. You're always slightly too late. You check the Earth timer again, the conversion stings. 2 decades since launch, 2.5. For you, barely a tenth of that. 10 years of normalcy. Maybe less. And the world you left behind has faded like a dream you almost remember but can't explain to anyone. Dinner's done, you float the tray into the waste chute and return to the observation deck. Proxima b spins on, unmoved by your presence. And you? You sit quietly in orbit, living slow, moving fast, and watching a planet that has no idea what time it is. What your bones think of relativity. You stretch again, arms overhead, spine arching as much as the constraints of zero gravity will allow, and for the 100th time, you hear that subtle creak, not from the ship, from you, a familiar pop somewhere in your back, or maybe a click from your knee. Welcome to the hidden cost of time dilation. It may slow your aging, but your bones are still quietly filing complaints with management. Because here's the kicker. While time is warping around you, your body still operates on good old biological rules. You're aging slower relative to Earth, sure, but your tissues don't care. Your skeleton doesn't have a physics degree. It just knows it's not being used the way it's supposed to be. That's right. Space may make you a time traveler, but it also makes you soft. Let's get technical for a moment. In low gravity, or worse, no gravity, your bones start to demineralize. It's called disuse osteoporosis, and it's not cute. On Earth, your bones constantly respond to the pressure of walking, standing, and even just sitting upright. Those forces tell your skeleton, hey, stay strong, we still need you. Out here, no such luck. You float. Your bones sulk. Calcium starts leaching into your bloodstream like your skeleton's trying to quit its job early. Historically, this has been one of the biggest physiological challenges for astronauts. Even on the International Space Station, astronauts lose up to 1% of their bone mass per month. That's with exercise routines designed by teams of slightly sadistic NASA physiologists. Without it, you'd be a sentient pudding cup in about a year. You try not to think about it as you do your daily resistance band routine. It feels like punishment at this point. Your arms tug against the taut cords, muscles shivering. Somewhere in your femur, a tiny part of you sighs. It's not just the bones either. Your heart. It gets lazy too. Gravity usually pulls blood downward, so your heart works against it. Out here, with blood floating freely, the heart doesn't have to pump as hard. Over time, it weakens. Your muscles follow suit, shrinking like unused dough. Your immune system? That goes a little haywire too. Cells get confused. Some stop working, others go into hyperdrive. You're aging slower relative to Earth, but inside, you're becoming a biological funhouse. Let's not forget the fluid redistribution. Without gravity holding your fluids down, everything floats upward. Face puffy, sinuses full, legs skinny. Astronauts call it moon face. Not quite as poetic as it sounds. Still, you're not just falling apart, you're adapting. You learn to move differently, to float with intention, to hold your breath when bending around tight corners so you don't knock your shins on a storage panel. Again. And yet, every day that passes in your slowed down frame is another dozen Earth days ticking away. Every morning routine is now an investment in a body that might be more myth than man by the time you return. You stretch, lift, resist, hydrate, and wonder. Will Earth even know what to do with you when you come back? That question lingers, because as you live in this compressed tempo, The world you left behind keeps racing ahead, and their medicine, their technology, their understanding of what you are, biologically, may have moved on. Historians still argue whether early space programs underestimated the psychological and physiological toll of long-duration missions. The records show plenty of excitement about weightlessness and cosmic discovery, but not much talk about spinal discompression or deep loneliness. Funny how launch plans always leave the messy parts out. Now here's a quirky little fact. In the 1960s, Russian cosmonauts experimented with centrifuge beds designed to simulate gravity by spinning the human body. The idea? Trick the bones into staying strong. The result? Nausea. Lots of it. Humans, it turns out, aren't fond of being swung around like laundry. Modern ships like yours avoid that route. Instead, you use resistance suits and elastic harnesses that make every movement a miniature workout. Your clothes are tailored to keep you uncomfortable enough to stay strong. It works, sort of. You're not disintegrating, just stiff. And yet, here's the strange bit. Despite the atrophy, the stretching, the sluggish blood cells and the fragile bones, you're still, technically, aging slower. Your chronological age is frozen in molasses thanks to relativity. But your biological age is pulling subtle tricks behind your back. Scientists debate this, by the way. The idea that time dilation affects biology at the molecular level is still an open question. Some say yes, every process slows down. Others argue that gravity, radiation and isolation play a far bigger role than time dilation ever could. You're in the middle of that debate now. You are the debate. Outside, Proxima b still glows in rust-coloured twilight. Inside, your body hums through its daily complaints. Joints whisper, muscles yawn. You write it all down in your log, like a scientist studying an exotic species, which in this case is you. You float to the medical bay and run a scan. Bone density? Low, but stable. Muscle tone? Acceptable. Heart rhythm? Slow, steady, and slightly sarcastic. It's amazing what the body can adapt to when time gives it the chance. You glance at the ship's clock. 1 year for you, 8 for Earth. You imagine people down there living faster, aging in real time. Your little niece is probably older than you now. Married, maybe. Kids. You used to read her bedtime stories. Now she might be reading your mission log as a bedtime story to her grandchildren. You check your pulse. Still there. Still slow. You sigh. Because relativity didn't make you immortal. It just gave you the illusion of a longer life. Your bones crack again as you reach for a protein pouch. Relativity, it turns out, is a terrible chiropractor. The twin paradox, sleepover edition. You're brushing your teeth, again, with a toothpaste that insists it's space-optimized, but tastes like wet chalk and minty regret. In the mirror, your face looks the same as it did yesterday, and the day before that, and probably the month before that too. Still smooth, still ageless. The creases you expected by now haven't shown up. Your eyes haven't dulled. Your reflection keeps insisting you're somewhere in your 30s, even though Earth has put decades between your last selfie and now. And that's when it hits you again. The twin paradox. It's one of those things they warned you about in astronaut school. Not just the physics of it, but the feelings. The emotional landmine of surviving time like this. It's not just about clocks anymore, it's about the people you left behind. And if you had a twin, someone born with you, someone who once shared your timeline, your birthday cake and your bedroom, well, now you have the strangest party trick in human history. Because you took the fast ship, and they stayed home. On paper it's simple. 2 genetically identical humans. One goes on a near light speed journey through the cosmos. The other stays put on Earth. When the traveller returns, they've experienced significantly less time. The Earthbound twin has grey hair, grandkids, and a whole lot of history you missed. You're basically fresh out of high school. Sounds like sci-fi, but it's pure physics. It's the natural consequence of special relativity. Time slows down for objects moving close to the speed of light, as measured from the perspective of someone who isn't moving. The faster you go, the slower you age relative to the person who stayed behind. The paradox comes from intuition, not math. Because from your frame of reference, coasting through space in this ship, you could argue that they're the ones who are moving. So why didn't they age slower? Historians still argue about who first phrased it in terms of twins. Some say Einstein himself used the example informally. Others point to later popularizers like Paul Langevin, who introduced it in 1911. Either way, the concept stuck. It became the example for explaining how mind-bending time dilation really is. The trick, of course, lies in the asymmetry. One twin has to turn around. The moment you decelerated, flipped your ship around and came back to your point of origin, you experienced acceleration. That breaks the symmetry. Your twin stayed in one inertial frame the whole time. You didn't. That's why you age less. The math is solid. The logic checks out. The emotions messier. Imagine it this way. You left your twin during a summer rainstorm. They waved from the tarmac while your ship ascended through the clouds. You blinked. You napped. You sipped coffee and floated. A few years passed. Your time. You've written a few journal entries, stared at a few stars, and now you land back on Earth. The tarmac is gone. The airport is a museum. Your twin, if they're still alive, has laugh lines and a cane. Maybe a prosthetic leg and an encyclopedic knowledge of things that didn't exist when you left. You look at them and say, "Hey, remember that movie we watched together?" And they smile and reply, "Which one?" There have been 17 remakes. You're not older or younger in any mysterious magical sense. You're not in stasis. You're just someone who took a shortcut through time by moving fast. Your twin was walking the scenic route. You took the bullet train, physics edition. Quirky fact, the twin paradox was once considered a proof against relativity by skeptics. Early 20th century critics argued that it couldn't make sense for one twin to age differently. The problem? They didn't understand acceleration. Once that was factored in, the whole system snapped into place like a jigsaw puzzle that was just waiting for someone to stop sitting on the corner piece. Now think about what it feels like to be the younger one. Not biologically, you're grateful for the lack of crow's feet, but emotionally, you're misaligned now. Someone who was once in sync with your every heartbeat now walks with a different rhythm entirely. You missed weddings, funerals, probably the collapse of at least 3 social media platforms. You tap your ship's screen and bring up archived messages. Your twin's video logs play chronologically, hair slowly greying, background changing, voice deepening or softening with age. You left a person with your mannerisms and inside jokes. You're returning to a stranger who wears your memories like antique jewellery. Beautiful, but a little out of fashion. And what do you say when you meet again? "Hey, I missed you," feels inadequate. "Why are you older than me now?" feels cruel. "How do we catch up?" is probably the most honest. Because relativity doesn't offer a way back. It doesn't let you rewind. All it gives you is a slower pace, a way to skip ahead while others do the living for you. Some part of you wonders if your twin resented it, if they envied your time capsule life, or if they pitied it. Because while you've been drifting in the slowed down future, they were busy doing the hard stuff, changing careers, losing pets, surviving heartbreaks, watching the climate and the world transform in ways you can't imagine. Maybe your twin left a message. You open the most recent log. They appear older than your last check-in. Wrinkled, calm, eyes still too familiar. They smile. "Hey," they say, "I thought about you this morning. Every year on launch day I still have cake. You always hated icing." You laugh. You forgot that. They continue. "I'm not mad, or jealous, or confused. I mean, I was. But now, I think it's just funny. How time did what time does. Took us different ways." They lean forward. "You'll probably get back here one day. I won't be around. But that's okay. I'll leave you the house and the garden. You remember how to cook, right?" You pause the message. Let it hang in the air. Because suddenly, the twin paradox doesn't feel like a thought experiment. It feels like a very long-distance sleepover that got out of hand, and you're the one who stayed up too late. How to skip 10,000 years by accident. You lean back in the padded contours of your flight couch, arms folded across your chest, staring at the navigation logs like they just insulted your intelligence. The numbers don't lie, but they sure know how to ruin your day. According to the latest mission data, Earth time has skipped ahead. Not a few years, not even a century. 10,000 years. Oops, you blink. Your brain does that thing where it tries to wrap itself around the absurd and decides instead to just quietly file it under denial and move on. Because how can you accidentally travel 10 millennia into the future? Relativity. That's how. Let's rewind. Remember how time slows down for you the closer you move to the speed of light. That slowdown isn't linear, it's exponential. The closer you get to light speed, the more dramatic the effect becomes. So if you go fast enough for long enough in just the right direction, your internal clock might say a decade has passed, while Earth's calendar lurches into the 120th century like it forgot to pump the brakes. This is not hypothetical. The math supports it. And now, so do your flight logs. Of course, this wasn't the plan. You weren't supposed to skip that far ahead. The mission brief was clear: a controlled relativistic cruise to Proxima Centauri, some orbiting, some data gathering, maybe a few selfies, then back home, 10 years round trip, max. But somewhere along the way, somewhere between course corrections and overambitious speed boosts, you crept a little too close to light speed and stayed there a little too long, just enough to warp time around you like a noodle in a microwave. Now Earth is ancient. You hover in front of the comms panel wondering if it's even worth sending a message. There's no guarantee anyone's listening. For all you know, Earth isn't even called Earth anymore. It might be a museum, or a myth, or worst of all, a shopping mall. This is the quiet dread of deep time travel. The realization that you might be the last living remnant of your original century. A walking, floating fossil from a time when smartphones still had glass screens and cats were internet famous. A quirky historical note. In 1907, physicist Hermann Minkowski redefined time and space as a four-dimensional continuum, space-time. He said, "Henceforth space by itself and time by itself are doomed to fade away into mere shadows." Cute. But he didn't mention what happens when you overshoot the shadow by 10 millennia. Your ship, ever helpful, tries to cheer you up. Autolog. Ship time, 9 years, 3 months, 14 days. Earth time, 10,324 years, 87 days. Mood, undefined. You laugh, sort of. Here's the thing. You're not dead. You're not dreaming. You're still you, right down to the coffee stain on your shirt and the crick in your neck. But everything you ever knew is gone. Not just family, not just cities, but ideas, cultures. Entire eras of human activity have passed by like a parade while you were napping at warp speed. You can't just stroll back and pick up where you left off. Time doesn't work that way. The past is sealed behind you like a door welded shut. And the future, you've arrived. Early, late, out of order, whatever. You're here now. Historians, or probably future historians, will debate whether this kind of one-way time jump counts as time travel or just irresponsible scheduling. Either way, you've skipped more human history than any single person ever has. You peer out the viewing window. The stars haven't changed much. Not yet. They take their time. But the patterns are slightly off. A few constellations stretched, others missing. Betelgeuse? Gone supernova maybe. Polaris? No longer north. Familiar skies turn strangers. And that's the weirdest part. The universe doesn't feel different. Time has leapt forward, but space hasn't caught up emotionally. The vacuum is still silent. The stars still shine indifferently. Your tea still tastes like lukewarm battery acid. But somewhere down there, on some version of Earth, if it still spins at all, everything has changed. Fringe theory time, some physicists believe there may be a point where relativity and quantum mechanics intersect to produce observer effects on time perception. Meaning, it's possible that by experiencing this massive time gap, you're reshaping the narrative of history just by being here. Which sounds poetic until you remember that no one may be around to hear your poetry. You scroll through mission records and dig up an old Earth news archive. It's dusty with corrupted data and glitchy video files. You find a clip from the year 2472. A man in a teal suit says, "We've decided to deprioritize crewed interstellar travel. Too risky. Too lonely." He blinks at the camera like he's half apologizing to you personally. You sigh. You wonder if you were the cautionary tale. Your logs are still intact. 9 years of journal entries, casual observations, jokes, ramblings about lasagna. These may now be the most valuable human documents in existence. Or maybe they're completely irrelevant, like a caveman's rock etchings misfiled in a digital library. No one told you how quiet 10,000 years feels. You decide to land. Not on Earth, not yet. But on the planet you've been circling. It has an atmosphere now. That wasn't in the earlier data. Life, maybe? Evolution given time to stretch its legs? 10,000 years can work wonders on microbes after all. You prep the descent module. It groans, just a little, like an old man being asked to stand up after a long nap. You know the feeling. As you guide the ship downward, you wonder what you'll find. A future that remembers you, or a future that doesn't care. Either way, you're going to step into it slowly, carefully, and very out of date. You were trying to travel a few light years, and you wound up time jumping into a new world, by accident. The black hole cheat code. You're weightless, drifting near the edge of a cosmic behemoth, a black hole so massive and ancient that its gravitational pull is warping space, time, and probably your sense of rational decision-making. You didn't plan to get this close, no one in their right mind would. But here you are, perched near the event horizon, the point of no return, staring into what looks like a hole in the universe, a place where light itself goes to disappear, and you're just floating here, casually, like a tourist on the lip of oblivion. This is what physicists sometimes refer to, half-jokingly, as the relativity cheat code. Want to experience time travel into the far future without building a fancy warp drive or circling the galaxy at near-light speed? Just drop into orbit around a black hole, hang out long enough. When you finally come back up for air, the universe has moved on without you. But let's slow down. First, you should understand what this thing is. A black hole isn't a hole at all. It's a collapsed star, a mass so dense that not even light can escape its gravity. Think of it as gravity having a nervous breakdown and collapsing in on itself. The math gets fuzzy at the centre, what's charmingly called a singularity, but the part that concerns you is the event horizon, the boundary beyond which nothing returns, not even awkward text messages. Out here, just outside that invisible wall, you're safe, technically, but the closer you get, the more dramatic time dilation becomes. This isn't just your typical fast ship kind of time dilation. This is gravitational time dilation, general relativity's other party trick. The stronger the gravity, the slower time moves, and black holes, they're gravity's final boss. Historians still argue whether Einstein ever truly believed black holes could exist. His equations allowed for them, but he was weirdly uncomfortable with the idea, like someone who invented chess but hated playing it. It took decades for the physics community to accept black holes as real and not just mathematical curiosities. Now we have photos of them, sort of, glowing halos of doom, captured in radio wavelengths, and now you're sitting next to one. Here's the math-defying part. The deeper you fall into the black hole's gravity well, the slower your clock ticks compared to the rest of the universe. From your point of view, nothing feels strange. You eat your meal pouches, do your stretches, complain about your aging playlist. Business as usual. But to someone watching from far away, you're practically frozen in time. Spend a few hours here and centuries might pass outside. Plan it just right, and you could return to a universe that looks nothing like the one you left. It's like being in a spa where the rest of reality is on fast forward. Just, with a slight risk of being shredded into spaghetti. Yes, spaghettification is real. It's what happens if you do cross the event horizon. The gravity gradient becomes so extreme, stronger at your feet than your head, that you get stretched into a long, thin noodle. Not metaphorically, literally. Best to stay in orbit, thanks. You keep a respectful distance, you're no fool, but you are curious. The experiment, if you can call it that, is working. Your ship's chronometer keeps chugging along, but your Earth clock, it's sprinting. You send a signal back home and get an automated reply from a server that sounds like it's been patched together with duct tape and panic. Message received. Date: Earth year 14,208. You sip your electrolyte tea and try to comprehend that number. 14,000 years. It sounds made up. Like you're living in the epilogue of someone else's sci-fi novel. You run a diagnostic, your body's doing fine, you're aging slowly. Too slowly, really. If you stay in this orbit much longer, you might find yourself staring down the next mass extinction event on Earth, or whatever planet replaced it. Quirky fringe fact. Some theoretical physicists have mused that black holes could be used to observe the entire future of the universe. Because time slows to a crawl near the event horizon, in theory, you could look outward and watch galaxies evolve, stars die, civilizations rise and fall, all in the span of a personal afternoon. But only if your eyes and mind could handle it. Spoiler, they probably can't. You record another log entry. Day 3 near the black hole. Earth time has advanced roughly 600 years since I arrived in orbit. I'm still here. The black hole is still black. Surprisingly few screaming souls or interdimensional tentacles. Honestly, I expected more drama. You glance again at the swirling accretion disk around the black hole, an inferno of matter heating up as it spirals inward, glowing brightly in X-rays and gamma rays. It's beautiful in a terrifying, absolutely do not touch kind of way. Like a nuclear lava lamp. A soft alert pings, you're nearing your planned departure window. If you don't boost out of the gravity well soon, your orbit will decay. And decay leads to, well, noodles. One more lap, you think. Just one more. But then it hits you. How many last laps have you already done? If you've been here for just a few days ship time and thousands of years have passed on Earth, what happens when you go back? What if no one can receive your signal anymore? What if language has changed? What if humans have evolved into something unrecognizable? What if they've turned into math, or light, or nothing? You feel it again, that deep pulse of loneliness that relativity never really warned you about. Because it's not just about moving through time, it's about leaving everything behind, often without realizing it. You send one final message, just in case. I was here, I watched time move, I stayed a little too long. If you're out there, I hope you're happy. I hope you made it. You fire your engines, the ship groans as it claws its way out of the black hole's grip. Time begins to unstick itself, seconds return to normal. Your Earth clock slows back down, but it's too late. By the time you're free, it's Earth year 29,000. You left as a curious traveller. Now you're a cosmic relic, but at least you beat the system. Sort of. Near-light travel on a student budget. You sit back in the command chair, feet hooked under a console to keep from drifting, and stare at your ship's energy readouts. They're not great, not terrible either, but definitely giving off that check engine light but in space kind of vibe. It's a quiet reminder that while time dilation lets you travel into the future, travelling at all, especially this fast, comes with a cost. And no, not just emotional, literal, astronomical fuel costs. You're moving at a speed so close to the speed of light that decimal points become philosophical. 99.999 something % of c, the cosmic speed limit. To go even a smidge faster now would take a laughably huge amount of energy, like drain a star levels of ridiculous. Which brings us to the awkward truth. Near light speed travel sounds like something you'd find on the back of a cereal box, but actually doing it. It's the most energy-hungry thing humanity's ever dreamed of. And your ship, efficient as it is, runs on the scientific equivalent of an overachieving go-kart strapped to a nuclear reactor. In theory, you need more than just a big engine. You need an absurd engine. Let's start with what the physics demands. As an object with mass, that's you, you can't reach the speed of light. Every tiny increase in velocity makes you heavier, more sluggish, more stubborn. The closer you get to light speed, the harder it is to keep accelerating. By the time you hit 99.9999% c, it takes exponential energy to gain even a decimal's worth of speed. It's like trying to jog through molasses while someone adds bricks to your backpack every second. Early 21st century engineers toyed with several concepts to solve this problem. Chemical rockets, laughably weak. Nuclear thermal, better, but still nowhere near good enough. That's when the more ambitious, some might say desperate designs started cropping up. Antimatter engines were one of them. Yes, antimatter, as in the exact opposite of matter. Put the two together and they annihilate into pure energy. Very dramatic, very efficient, also wildly dangerous and expensive. Producing even a gram of antimatter would cost trillions. You could fund a planet-wide streaming service for less. And store it? Let's just say you don't want to be anywhere near it if your containment field flickers. Still, it's what your ship uses. In microscopic quantities, carefully magnetically trapped. Every few days, a molecule of antimatter meets its match and boom, you keep moving. Just don't sneeze near the reactor. There were other designs too, theoretical ships powered by solar sails pushed by lasers. Concepts that involved scooping hydrogen from space and using it as reaction mass. Even the occasional proposal to ride gravitational waves like some interstellar surfer. Fringe ideas, born of desperation and caffeine. Historians still argue whether the final design for your ship was genius or madness with good marketing. Regardless, it works, mostly, with the occasional groan, but your real fuel isn't antimatter, it's math. Because what really gets you into the future is speed and patience. The fuel just helps maintain your velocity. The time dilation is baked into the universe, no upgrades required. The faster you go, the less time you experience and the more history you passively skip. A fun fringe idea. Some ultra-frugal theorists once pitched the concept of cosmic slingshot sleeping pods. You launch a pod at high speed using gravitational assists, let it drift for a few hundred years Earth time, then scoop it up on the other end. Low fuel, low comfort. Basically a space coffin with better ventilation. You shudder. You'll take your antimatter espresso shots, thank you. Still, your ship isn't a cruise liner. It's more like a long-haul truck from the future. Functional, Spartan, barely big enough for you to do jumping jacks in without punching a wall, and your supplies, carefully rationed, freeze-dried, vacuum-packed, and questionably flavoured. One packet is labelled pizza, but tastes like cardboard and artificial nostalgia. You've learned to savour the little luxuries, the recycled water that doesn't taste too metallic, the playlist you forgot you loved, the comforting groan of the magnetic treadmill as it simulates gravity just enough to stop your legs from turning into spaghetti. You scroll through the Earth time log again. 5,000 years gone, or 10, you're losing track. For you, it's been about, 8 years? Maybe 9? You're skipping through time like someone fast-forwarding through commercials. Only the commercials are entire empires, geological eras, lost languages. And speaking of languages, communication gets weird. You've got translation algorithms built into your system, but even they start getting confused as Earth's language morphs. Syntax changes, pronunciation shifts. You get messages filled with emojis, non-verbal gestures, and bursts of audio that sound like jazz for dolphins. You record a reply anyway. This is ShipX 2031, chronologically off by about 7 millennia. Still in motion, still alive, still a little annoyed by the food. No one may ever hear it, but it makes you feel better. And then comes the panic moment. An alert. Energy levels dipping faster than expected. A coolant loop glitch, a miscalculation, maybe some extra mass picked up from stray particles in deep space. You mutter a curse your onboard AI pretends not to understand, you open the manual. It's written in a font that was trendy 1,000 years ago. A footnote warns, in very small print, in case of system anomaly, do not panic. Breathe deeply. Consider writing a poem. You laugh. Then consider writing a poem. Eventually you stabilize the system. Maybe. You're not sure. The lights stop blinking, that's usually a good sign. You run a diagnostic that takes 14 seconds ship time, about 30 years Earth time. You've learned to stop obsessing over numbers. Because on a student budget spaceship, one built with cost efficiency, patchwork engineering and hope, you're not just coasting through the cosmos. You're being held together by spit, duct tape and the sheer stubbornness of relativistic physics. And yet, you're still here, still drifting forward, still skipping centuries between lunch and dinner, because even when the antimatter's low and the tea tastes like space socks, the biggest engine on board is time itself. And buddy, time is always in stock. If you blink, civilizations change. There's a moment, somewhere between cleaning out the ship's air filters and rehydrating a pouch of cheddar-flavoured protein mousse. A culinary crime you're pretty sure is illegal on at least 3 planets. When you finally look at the Earth feed again, just a quick peek, you tell yourself it's nothing, just curiosity. But you know it's more than that. You've been avoiding it. And now, here it is, the Earth, or at least something very Earth-adjacent. Because while you were vacuuming lint from the oxygen recycler and doing your awkward zero-G lunges, everything changed. Again. The feed is patchy, fragments bouncing through the interstellar relay network, but what you do get makes your pulse stutter. The continents are mostly familiar. Africa still stretches proud across the middle. Asia looms large, but coastlines have shifted. Oceans creep where they shouldn't. There's an inland sea somewhere in what used to be Siberia. Australia is greener. And then there are the lights, patterns of cities scattered like embers, but glowing in strange clusters. Some vertical, stretching up into orbit. Others, underwater. You scroll through the message logs and spot the timestamps. Earth year 51,921, you rub your eyes, blink. When you launched, people were still excited about reusable rockets and arguing over whether AI should be allowed to paint. Now your last recorded birthday is ancient history. You are ancient history. And yet you don't feel old. You don't even feel sleepy, just stunned.
Because out here, time moves like syrup. A few months for you, maybe a year. And in that blink, civilizations have come and gone. The feed flashes a short video, someone or something speaking to camera. The being is humanoid, tall, smooth-skinned, eyes slightly too large. Speech is melodic, punctuated with gestures that your translation AI struggles to interpret. It spits out a rough caption. We honor the ancestor astronauts, still in orbit, still listening. Wait. Ancestor? You look around your ship like it might suddenly answer back. You check your face in the reflective panel. No wrinkles, no silver hair. You look the same crooked smile, same tired but hopeful eyes. And yet, you're an ancestor now. They're talking about you. You're not a traveler to them. You're a relic, a legend, some wandering myth from the pre-digitized age who vanished into the stars and never came back. It's flattering in a deeply unsettling way. Historians still argue whether the earliest plans for interstellar travel ever took this into account. The idea that a living human might someday return to a world so far removed from their own that they'd be seen not as a visitor, but a figure of folklore. You remember a quote from some ancient book, possibly on a coffee mug. You either die a pioneer or live long enough to become your own origin story. A bit dramatic, but it's starting to feel alarmingly literal. One of the archived transmissions shows what looks like a school. A teacher, or possibly a telepathic neural guide, hard to say, is showing children a 3D model of your ship, the one you're currently inside, eating mousse that tastes like regret. The kids laugh. One points and mimics your haircut. It's apparently hilarious. You're a museum exhibit now, except the museum never closed. You wonder how many civilizations have risen and fallen while you were out here, shaving microseconds off your biological clock. Maybe a few collapsed, maybe a few transcended, maybe one uploaded itself into a crystal sphere and now lives inside a comet. You scroll through more Earth transmissions. One features music, odd scales, rhythms that feel like heartbeat patterns stretched across synthetic harps. Another shows an orbital ring encircling the planet, glittering like a planetary halo. You can't tell if it's transportation or a form of art. Probably both. And then comes the map, a full Earth political overlay. You blink at the names: Pan-Eurasian Cooperative, the Ring of Song, the Saline Republic, the hive mind of Hollow Earth. Somewhere in the corner, in barely visible letters, Heritage Territory, former United States. You chuckle. It feels like seeing your childhood home on a new map, labeled Ruins of Interest. But there's something beautiful about it too. Civilizations may rise and fall, but Earth, whatever it becomes, keeps going. People adapt. They build. They rename everything, then rename it again. They forget the old ways, make new ones, then decide the old ways were vintage and bring them back ironically. Time dilation didn't just let you skip the line. It let you witness what no human was ever supposed to see in a single lifetime: the evolution of culture itself. Languages mutate, religions split, fade, or merge. Technology builds, collapses, rebuilds again, and through it all, someone, somewhere, still remembers you, or the idea of you, a lone astronaut, blinking across millennia. Quirky fringe fact. A theory proposed in the 2020s claimed that time-dilated travelers like you might one day serve as continuity anchors. Humans who carry forward the memory of the past, not through data, but through personal memory, living links across eras, a kind of temporal diplomacy. Of course, others disagreed. One particularly snarky futurist called it emotional taxidermy, the idea of preserving a person just to parade them around in the future. You don't know which camp you fall into, not yet. You glance back at the Earth feed. A new message has arrived. It's shorter, a simple, glowing glyph that your system renders into a single sentence. You're welcome, always. That's unexpectedly touching. You float silently for a long while, the hum of the ship fading into the background. Outside, Earth turns slowly beneath the stars, ancient and newborn all at once. A world you know and don't know. A place you left and somehow returned to, even if it's a version that never expected to see you again. You blink. Another few days pass. And by the time you open your eyes again, another culture might be waiting to say hello. The party where no one shows up. You've landed. Not on Earth exactly, more like Earth adjacent. A quiet, stable region on one of the planet's orbital colonies, suspended in low Earth orbit like a glassy ring around the world. You descend in the drop pod like a guest arriving very late to a party. About 49,000 years late, give or take a century. And the strangest part? No one's here to greet you. You were expecting something. A crowd, confetti, a brass band, maybe just one wide-eyed intern with a clipboard and a nervous smile. But the docking bay is empty. Lights are on, the systems still chirp with polite artificial intelligence, and the air smells like citrus and static. But it's a ghost town. There's a message waiting, projected as soon as you step into the corridor. Welcome, traveler. We are not here in the way you expect. Do not be alarmed. You are not alone. Oh, great. Nothing like starting a conversation with philosophical ambiguity. You wander the station, boots tapping softly against polished flooring, past murals made from some kind of living crystal that changes as you walk. One panel shows your ship, your actual ship, curled in orbit like a sleeping insect. Another shows you, sketched in soft, exaggerated strokes, looking far nobler than you probably deserve. You've become a symbol, and symbols don't get welcome banners. It becomes clear fairly quickly. This place isn't abandoned. It's just not built for humans anymore. Not exactly. There are signs of habitation, but the kind that doesn't need chairs, or air, or linear time. The current inhabitants, whoever they are, have moved beyond the old ways. They didn't forget you. They just outgrew the party you were invited to. It's like showing up to a birthday celebration only to discover it ended a few centuries ago and the guests evolved into sentient Wi-Fi. You pace through what looks like a garden, but the plants sing, actual harmonies. A vine hums softly as you walk by, like it's acknowledging your presence. Your translator chip, outdated by tens of millennia, can't make sense of it, but you think the key is G minor. There's a plaque by a large reflective sculpture. To the ones who left and drifted forward, we could not wait. We did not want to, but we remember you. You sit on a bench made of warm, responsive metal and exhale. This was always a possibility. It was in the fine print. Even your early training included the awkward module labeled Cultural Dislocation and Post-Temporal Solitude. Back then, you joked about it. Oh no, I missed Thanksgiving. Guess I'll have to invent a new holiday. Funny how that joke doesn't land anymore. Historians, if they still exist, would probably point to this moment as a pivotal emotional beat. The traveler returns not to applause, but to absence. The future isn't waiting for you with open arms. It already moved in, rearranged the furniture, and now uses time in ways you can't follow. Fringe tidbit. There was a theory once that long-term relativistic travelers would eventually encounter a cultural singularity, a moment where technological progress outpaces the ability of any time-delayed individual to integrate. You're there now. Not because they don't want you, but because they can't reach you. Time has made you unreadable. You're still you, still held together by bone and memory. But your jokes are outdated, your references, dust. The slang you know has passed from cringe to forgotten. You say, okay, and it sounds like Latin. So you throw your own party. You find a small communal area, still stocked with food, or its equivalent, and music interfaces that respond to emotional frequency rather than genre tags. You light the room in soft blues. Play a melody you remember from Earth just before you launched. It was playing on the radio as your ship sealed shut. The song was about the moon, or falling in love, or maybe pancakes. You hum along. No one joins in. The silence isn't hostile. It's just uninterested. Like arriving at a wedding where everyone already got married and moved to another dimension. You drink something clear and slightly fizzy from a glass that grows itself from the table. It tastes like memory. Or at least that's what the menu said. You sip again, hints of orange, or summer. You raise your glass to the empty room. To the future, you say aloud, your voice echoing softly. Sorry I missed the fireworks. There's a moment of stillness, then a flicker on one of the walls. A figure appears. Not real, not quite holographic, a projection, archival. She looks human or close. Broad smile, slightly transparent hands. If you're seeing this, she says, you made it. That means, well, that means you were right. Or lucky. Or incredibly stubborn. You smirk. All of the above. The figure continues. We're not here anymore, not in the way you understand. We've moved on, not because we didn't care, but because caring doesn't require proximity. You are remembered. That's the gift we leave you. The recording ends. You sit for a long while after that. Eventually, you write a message. Just a short one. I got your invitation. Sorry I couldn't come sooner. I brought my own snacks. You leave it on the system, encrypted but open. Someday, maybe someone, or something, will read it. Maybe someone will host a retrospective or tell a story about the time traveler who came home and found no home left. Or maybe they already did. 1,000 years ago, the party's over. But you were on the guest list, and you showed up, even if no one stayed for the cake. Time tourism, rated 1 star. So, you did it. You time traveled accidentally on purpose, with physics instead of phone booths, and you made it all the way to the future. Thousands of years past your departure date, you arrived intact. You weren't squished by gravity. You weren't fried by cosmic radiation. You even managed to keep your socks in pairs. And what's your reward? Absolutely no amenities. No guided tour, no translators, no welcome packet with shiny pamphlets titled, Your First 10 Millennia in the Future. What to expect when you're disoriented. Instead, you got one politely cryptic hologram, a vine that hums, and a fizzy drink that possibly gaslit you with memories of orange juice. Time tourism, it turns out, is not what the brochures promised. You wander the city, or what's left of it. It's beautiful, in a way that feels more like art than architecture. Buildings are grown now, not built. Materials shimmer and shift. Surfaces respond to mood. Everything's too smart for you. You once prided yourself on understanding your ship's entire engineering layout, and now you can't even find the bathroom without negotiating with a door. There's no currency, no signs, just impressions, color changes, holographic ripples in the air that seem to react to your thoughts, or possibly your blood pressure. You keep hoping for someone, something, to talk to. But it's all automated, quiet, designed for beings who probably exist half in reality and half in the cloud. Maybe they don't even have bodies anymore. Maybe they visit in dreams or stream themselves into synthetic hosts. Maybe they've moved on to a different layer of time altogether, like upgrading from 2D to 4D and deciding to leave you behind with the flip phones. You sit on a bench that purrs when you're sad. Cute, but not helpful. You remember how excited people were, back in your launch era, about the idea of future tourism. There were books, articles, think pieces titled things like How to Vacation in the 41st Century and Bucket List, Shake Hands with a Post-Human. The dreams were always the same. See flying cars, take selfies with robots, eat whatever synthetic dessert replaced chocolate, and return with stories no one could beat. But nobody mentioned the crushing loneliness, or the language barrier, or the fact that everyone you knew would be long dead and possibly recycled into stardust. Fringe historical side note. A 23rd century travel startup once tried marketing a service called Time Windows. Customers could ride high-speed orbits for mild time dilation, then return home slightly futuristic. The pilot program failed miserably. One traveler returned 10 years later to discover her cat had died. Her apartment was now a noodle bar, and her boyfriend had married their former roommate. 1 star on all review sites. That's the problem with time travel. It's fundamentally incompatible with expectations. You can't plan for a culture that hasn't evolved yet. You can't study a language that hasn't been invented. You can't ask someone for directions when they've uploaded their consciousness into a mineral and prefer to communicate via ultraviolet strobe pulses. You check your ship's systems again. Still working, still old. The AI occasionally tries to recommend music based on your mood, but its library hasn't updated since the year 3200. You're stuck listening to synthwave remixes of Gregorian chants. You try to leave a review. It feels silly, but also necessary. Time tourism log, entry 03, accommodations, ethereal, possibly conscious, unclear. Hospitality, 2 out of 10. No towels, no hosts. Food, ambiguous. 1 item tasted like disappointment and lime. Activities, wandering, talking to walls, occasional existential crisis. Overall, great view, bad company. Would not time travel again without insurance. You pause, then add, bonus star for the stars, still beautiful, still familiar. You float again. Gravity is weird here, local and optional. And think about why you came in the first place. Was it curiosity, ambition, the promise of doing something no one else had done? Or was it the hope that you'd find something better out here? Something evolved, something that would look at your messy little 21st century self and say, wow, you made it, you matter. Instead, they moved on, which is kind of the point. Because time doesn't wait. Not for kings, not for explorers, not for lonely astronauts with stubbornly analog hearts. The future doesn't exist to impress the past. It exists in spite of it. You remember an old quote, something one of your instructors said during early training. The future doesn't need your permission, it just needs your absence. At the time, you thought it was poetic nonsense. Now, it sounds more like a farewell. You make your way back to the ship. It's still docked, gently tethered to a station that doesn't care if you stay or go. You power up the system. The interface flickers, stutters, then stabilizes. Your name appears, the last thing in the system that still feels familiar. And yet, you hesitate. There's no mission anymore, no clear path. You can't unsee the future, can't walk into the lobby and ask to speak to a manager. There's no refund, no return shuttle. Just one question. Do you stay here? A lone anachronism drifting in orbit, watching the world from the outside? Or do you move forward again, skip even farther, press fast forward again, hoping there's someone on the other side who might wave back? You check your navigation panel. A course blinks gently. A distant system, 14 light years away. If you maintain current speed, it'll take 6 months ship time. Earth will age another 12,000 years. You raise an eyebrow. Let's try again, you whisper. Maybe someone's home over there. You close the hatch, 1 star for the party, but 5 for the view, catching up with dead languages. You're halfway through decoding a message scrawled across a public terminal when you realize something humbling. You've spent the last 4 hours trying to figure out what is either a poem, an advertisement, or a warning to keep your limbs inside the transit pod. Hard to say. The language, it's not unfamiliar exactly. There are echoes of syntax you almost recognize, symbols that vaguely resemble letters from long-forgotten alphabets. Some parts feel like a weird blend of Mandarin and emoji. Others read like someone tried to translate Shakespeare into binary using interpretive dance. You'd laugh, but you're starting to sweat. Because in this version of Earth, if this is still Earth, language has moved on, or fractured, or evolved into something that doesn't just sound different, but thinks differently. And you? You're the one who didn't get the memo. You crack your knuckles, pull up your ship's ancient translation module, and feed it the inscription. The system blinks for a moment, coughs up a result, and then crashes. A second later, it reboots with a single helpful note. Target language not found in historical lexicon. Suggested action, try guessing. You sigh. This is not new. You've been running into these gaps since the last orbital station, where a vending machine offered you a beverage called Synthought Fusion Pulse that turned out to be mildly hallucinogenic, possibly sentient. Language isn't just a communication tool, it's the operating system of civilization. And here you are, running version 1.2 in a world that's on 947.b. Historians still argue whether time travelers like you should be classified as ambassadors, survivors, or glorified software glitches. Because what you call language, the way you arrange vowels and consonants into neat little packets of meaning, is now quaint at best, obsolete at worst. Even spoken language itself? Not guaranteed. You pass 2 locals, humanoid-ish, maybe augmented, and watch them converse by flashing pulsing patterns through tiny light nodes embedded in their forearms. It looks like Morse code wearing a rave costume. No mouths move, no sound, but they seem to understand each other perfectly. Your wrist translator doesn't even try to interpret. You wave awkwardly, they nod politely as if recognizing a cultural fossil trying its best. Quirky side note. In the 2400s, a group of linguists formed a cult-like academic circle called the Silentists. Their goal was to eliminate spoken language entirely, believing it was too inefficient for future cognition. They developed an elaborate gesture and glance-based dialect. It lasted about 5 years before being replaced by direct brain link messaging, faster, quieter, and with fewer awkward hand signals. Now, here in the future you've landed in, language seems to have fragmented and recombined in ways no one from your time could have predicted. Some groups still speak aloud, but it's fast, clipped, and heavy with inflection that changes the entire meaning of a word based on your heartbeat or breathing pattern. Others just think at each other. You try to adapt. You upload several terabytes of linguistic data to your ship's AI and begin training modules. A crash course in transgestural syntax, a module on rhythmic tonal pulses for polite disagreement, and one charmingly titled, How Not to Accidentally Declare War with Your Eyebrows. It's slow going, and all the while you can't help but feel a little absurd. You once read books, real books, with pages, about lost languages, ancient tongues like Latin, Sanskrit, Old English. You used to think it was tragic when languages died. Now you realize they didn't die. They just kept walking forward without you. You imagine someone trying to decode your old texts now, a letter to a friend, a status update from your ship, a sarcastic tweet. What would they make of it? Would LOL confuse them? Would your use of literally be interpreted? Literally? You leave a note on a wall, just a simple line, scratched into a surface that might be stone, or some kind of advanced polymer that regenerates every 24 hours. I was here. I tried to understand. You know they might not read it, but maybe they'll recognize the effort. Because language isn't just about syntax. It's about reaching out, across barriers, across time, across the yawning void of missed context and missing grammar. At a marketplace, or what functions as one, you try to buy a snack. You point. The merchant, you think that's the word, gives you a sequence of tones and flashes a symbol at your wrist. Your AI makes a whirring noise, then says in a politely panicked voice, "That is either a payment request or a marriage proposal." You cancel the transaction, quickly. Later, back on your ship, you pore through logs of known extinct languages. You listen to old recordings, clicks from the Khoisan languages, the slow, haunting syllables of Ainu, the rhythmic chants of Old Hawaiian. You realize they're all buried in your memory now, echoes of sound no one uses anymore, and now your own tongue, your native language, is joining them, becoming a fossil. You're a living speaker of something the universe no longer speaks, a lone voice trailing behind an evolving chorus. And you think, maybe this is the ultimate time traveler's curse. Not the solitude, not the disorientation, but the incomprehensibility. You can survive in the future. You can breathe and eat and sleep, but you may never again belong in a conversation. Still, you try, because what else is there? You record yourself reading a bedtime story from your childhood. You send it to the archives of the local network. Maybe some future archivist, some child curious about presentient dialects, will listen and hear something strange and warm and distant. And maybe they'll think, this is what humans used to sound like. This is what they wanted us to remember. You sit in your pilot's chair staring at the logs, trying to find the right words, not the right language. You gave up on that hours ago. Just the right words. Something to say, something to leave behind. So you write one more line in your native tongue, whisper it to the humming silence of your ship. Still here, still listening. And maybe that's enough. What your absence does to history, you're floating again. Not in space, though technically yes, still in space, but in thought. Drifting through the corridors of your ship, quiet, reflective, your footsteps softened by a gravity field barely strong enough to justify shoes. Something has changed in you, not physically. You're still in your ship-shaped time cocoon, aging like molasses. But mentally, you've started to tug at a question you've avoided until now. What happened to the world because you weren't in it? You never considered yourself that important. Not a world leader, not a genius inventor. Just an astronaut. Qualified, sure. Lucky, definitely. But not someone history would hinge on. And yet, now that you've skipped forward by tens of thousands of years, the weight of your absence starts to stretch into focus. What changed because you weren't there to do the small things? It starts with the personal, the people you left behind, friends, family. People who knew your laugh, your favorite snack, your odd habit of talking to the plants in your kitchen. You imagine their lives continuing without you, filling in your silence with stories, with questions, with myths. Maybe someone waited for you longer than they should have. Maybe someone named their child after you. Maybe your empty seat at the dinner table became part of the furniture. You'll never know. Historians still debate the impact of a single person on the arc of time. The great man theory once claimed that individuals shape history through force of will. Later scholars pushed back, saying it's more about systems, cultures, accidents, economics. But you can't help wondering if your presence, or your lack of it, rippled in ways no one recorded. Back home, there may have been a conversation you never had, a vote you didn't cast, a small kindness you didn't give, a domino that stayed upright because your hand wasn't there to tip it. Time travel doesn't just move you, it removes you. It deletes you from moments and leaves the timeline to improvise. Fringe theory time. In the 29th century, a philosopher named Kelta Moru proposed the counterfactual temporal presence model. Basically, the idea that non-existence in a particular moment carries measurable weight. That by not being there, your ghost influence leaves a kind of negative space, an imprint where probability adjusts to account for your absence. People laughed, but her calculations showed subtle patterns in long-duration traveler cases, oddly timed scientific breakthroughs, interpersonal shifts, unexplained course corrections. Maybe not proof, but not nothing. You find a public archive during your last stop at a future station. The interface recognizes your presence as temporal variant, pre-deluge epoch. That's a new one. You search your name, it pops up, briefly, then vanishes. The database marks it as historical placeholder, unverified. So that's what you are now. A placeholder, a maybe, a ghost with a resume. You dig deeper. You find a few logs from your launch year. A news article. First solo relativistic traveler begins historic journey. Comments are mostly supportive. A few trolls joke about your odds of coming back with your sanity. You find a message from someone you knew, a sibling, a friend. It's short. He left today. I don't know what to feel. Proud, scared, like I just lost someone to a future I can't follow. Then silence. You wonder how long they waited before deciding you weren't coming back. A year? A decade? Did they tell their kids about you? Did your story survive family dinners? Or get trimmed away with the other awkward absences? You're not grieving exactly. It's more like reading your own obituary in a language you almost understand. There's no villain here. You left willingly. The mission was clear. The risk, accepted. But no one ever tells you what it feels like to be a missing piece in someone else's puzzle. Not dead, just absent. Permanently paused. You sit at the observation panel, staring at the stars that outlived everyone you ever knew. The ones that didn't need you, but saw you go. Would the world be different if you had stayed? Would the bakery down the street still have opened if you had been there to encourage the owner? Would your friends still have quit their job, or stayed in the city, or started painting? Would someone else have gone instead of you? Would they have come back? You sip from a warm pouch of something caffeine adjacent. It's bitter, comforting. You watch the stars blur slightly through the viewfield. Maybe just your eyes. Back on your ship's logs, you start a new file. Today, I'm thinking about what happens when you're not part of the story. Not because you died, but because you left it running without you. I didn't mean to miss so much. I just wanted to see what came next. You hit pause. You wonder if you'd made a bigger difference had you stayed. But that's the thing about time travel. You don't just visit the future. You abandon the past. You decide to leave a message for the world, a kind of breadcrumb. You patch into the local network and leave a public note tagged to your identity. It says, I was here. You didn't know me, but I was part of your history once, even if only as a silence. Maybe no one reads it, or maybe someone does and imagines you, floating out here, the missing heartbeat that once shaped their great-great ancestors' day. A time traveler, a ghost, a ripple, time dilation without leaving Earth. You're back aboard your ship again, orbiting high above a world that once bore your name. Well, a world. It still calls itself Earth, more or less, Though, if we're being honest, it's Earth in the same way that your childhood home is technically still the same house, even after it's been sold 5 times, turned into a pet cafe, and painted fuchsia. And now, as you prepare for your next long burn into the future, you catch yourself staring out the viewport and thinking not about where you're going, but where you never really left. Because here's a fun twist. You didn't need a spaceship to time travel. Turns out you've been doing it your whole life. Everyone on Earth has. It's just really slow. You think back to the lectures, the equations, the sweaty palms during astronaut psych briefings. They always made time dilation sound like a distant, high-speed kind of magic. Something that happens only when you flirt with light speed or drift too close to black holes. But here's the quieter truth. Time bends even on Earth, all the time. Right now, in fact. Literally this moment. Let's start with your feet. They're slightly closer to the center of Earth's gravity than your head. That means, brace for it, your feet experience slightly more gravity, which means time runs a teensy bit slower down there. Your head is technically older than your toes. Not by much, sure. A few nanoseconds per year, depending on your height and elevation. But still, your body is aging at different speeds. You are your own paradox. It's the result of gravitational time dilation, one of general relativity's weirder but thoroughly verified side effects. The closer you are to a massive object like Earth, the more space-time bends, and the slower time ticks in that warped zone. Historians still argue whether Einstein grasped how deeply unsettling this would be on a personal scale. Imagine telling someone in 1915 that standing on a mountain would make them age faster than someone at sea level. He probably did it with a grin. And speaking of mountains, people who live at high altitudes do age faster. Again, it's minuscule. Not enough to skip your next dentist appointment, but measurable. In fact, atomic clocks placed at different altitudes tick at different rates. In 2010, scientists placed 2 synchronized atomic clocks just 33 centimeters apart, roughly the height difference between 2 shelves, and the higher one ticked faster. Time dilation confirmed. On a shelf. In a lab. You chuckle, remembering how much money and fuel your ship burned trying to achieve what 2 clocks and a stool did with gravity and patience. But it's not just altitude. Speed messes with time too. The faster you move, the slower your time ticks compared to someone stationary. You don't have to be in space for this. Commercial airline pilots age just a little slower than people who stay on the ground their whole lives. GPS satellites? They experience both velocity-based and gravitational time dilation, and we have to correct for it constantly. Without those corrections, your phone would put you somewhere in the next neighborhood every time you tried to order lunch. Relativity is why your pizza finds you. Fringe detail. Some theorists once suggested that Olympic sprinters experience microbursts of time dilation every time they run. True, but the difference is so tiny that even Usain Bolt's wristwatch wouldn't notice. And yet, it's there. You pause your musings to glance at your ship's chronometer. For you, it's been, maybe 12 years? Earth, meanwhile, has danced through tens of thousands. But the truth is, you were already time-traveling long before your ship ever left orbit. The effect was just smaller, calmer, less dramatic. But still, you were always moving into the future at your own speed. Just very, very slowly. There's something oddly comforting in that, isn't there? That every moment, every heartbeat, every blink is a tiny time jump. That the universe gives you this built-in slipstream through time, even if you never leave your couch. It also means no one truly shares a moment, not exactly. 2 people in different positions, at different velocities, experiencing slightly different timelines. No absolute now. Just a smeared-out collection of personal frames of reference, stitched together by memory and mutual agreement. You remember a quote from one of your instructors, scribbled across the whiteboard during your final week of training. Time is local, everything else is opinion. At the time, you laughed. Now, it feels like the most honest sentence ever written. And if time is local, then Earth itself is a map of microclocks. Everyone aging just a bit differently, even if they all think it's 3:15 on a Tuesday. You wonder how many people lived their whole lives not realizing their head was older than their feet. You also think, just briefly, about the weirdly beautiful way this all comes together. No two people ever age at exactly the same rate. Not lovers, not friends, not twins. Every conversation you've ever had, every shared breath, was already out of sync before it began. We're all time travelers, passing each other like ships in slow-motion fog. So maybe your journey wasn't so strange after all. Maybe you just did the dramatic version. Everyone else got the extended cut, and now, here you are, about to launch again. Your ship hums softly. Your trajectory is mapped. Your course will take you even farther from the thread of now. More years will pass in the blink of your eye. More civilizations will rise. More languages will die. You run a last diagnostic, systems stable, mass within parameters, fuel, sufficient, barely. You smile. What's a time traveler without a little fuel anxiety? Before departure, you draft a note. Something to leave in orbit. Maybe someone will find it. Maybe someone already has. It reads, "Don't worry, you're time traveling too, just one slow breath at a time." And then you go. Engines flare, space folds, and the Earth, your Earth, the one you knew, shrinks into a glowing dot of history. You're still falling forward. And so is everyone else. Dreams of a universal clock. Time used to feel so solid, didn't it? It was this dependable thing. Tick-tock, sun up, sun down. Lunch at noon, bedtime at 10. Calendars, schedules, alarms that screamed you awake, meetings that made you question your life choices. Even out here in space, where you haven't seen a real sunrise in over a decade, ship time anyway, your body still remembers the rhythm. But the deeper you go into time dilation, the more you start asking a question you once thought only philosophers asked. What time is it really? Not for you, not for Earth, but for the universe. Is there some cosmic wall clock ticking behind the scenes? Some master timeline that everything syncs to? Is there a now that's real, absolute, everywhere? Spoiler, probably not, but don't feel bad. Physicists have been trying to nail this down for over a century, and it just keeps getting slipperier. See, according to Einstein's theory of relativity, time is local, not just in a vague, poetic sense. Literally, different observers can disagree on whether two events happened at the same time, and they can both be right. There is no universal now, just overlapping slices of reality smeared across the four-dimensional loaf of space-time. Each observer carries their own clock, their own perspective, their own version of the universe. It's like a party where everyone brings their own playlist and insists it's the only one playing. Historians still argue over the emotional fallout of this discovery. Did Einstein kill objective reality? Did he just politely tell Newton to take his grandfather clock and go home? There's a whole school of philosophical thought that mourns the loss of absolute simultaneity, as if humans were more comfortable when the universe at least pretended to play fair. But physicists? They leaned in. They looked to the stars, hoping something, anything, could give us a common frame. And the best candidate we've got? The cosmic microwave background. Imagine the afterglow of the Big Bang still echoing through the universe. A faint, microwave hiss coming from every direction, perfectly uniform, like the thermal ghost of creation. It's everywhere. And when you measure your motion relative to it, you can, sort of, define a rest frame. You're not syncing to a clock, you're syncing to a temperature. We call it the CMB rest frame. And in that frame, you can say, this is the universe's average perspective. This is what stillness looks like. Of course, you're not in that frame. Not really. Nothing is. Even the Milky Way is moving relative to it. But if you subtract all the motion, your ships, your solar systems, your galaxies, you get something close to a cosmic standard. It's not a clock, but it's the best we've got. And still, it's a little disappointing, isn't it? You were hoping for something grand. A countdown. A cosmic hum. Something that says, hey, it's 3:14 everywhere in the universe. Time for tea. Instead, you get this weird chorus of clocks, none of them agreeing. Some ticking faster, some slower, some freezing entirely near black holes. others racing forward near cosmic rays. And here's the kicker. Every single one of them is valid. Your clock, Earth's clock, a neutrino's internal decay timer, the slow drip of time near a neutron star. They're all right, just not right together. There's a term for this, proper time. It's the time experienced by a specific object along its specific path through space-time. No comparisons, no arguments. Just you and your little timeline, moving through the universe with your own personal metronome. Quirky side note, there was once a fringe theory, briefly popular in the 2050s, that proposed a quantum heartbeat of the cosmos, a ticking rhythm buried in the Planck-scale foam of space-time itself, something so small and fast that we haven't detected it yet. The theory fizzled out, but it stuck in the cultural imagination. Songs were written, calendars reimagined. One artist even tattooed themselves with what they believed was the pattern of the universe's heartbeat. Turned out to be Morse code for coffee break. Still, the dream persists. You think about your own clock now, your biological one. The heart that beats steadily in your chest, the cells that divide, the thoughts that flicker like neurons, fireflies. All of it has its own tempo, and that tempo hasn't changed, no matter how far you've traveled or how fast. To you, the seconds feel like seconds. To Earth, you've become a ghost. So is your clock more real than theirs? Or are they more real because there are more of them? You stare out at the stars and realize something soft and strange. The universe isn't asking you to agree on time. It's just asking you to move through it. Your ship drifts past a quiet nebula, softly glowing in ultraviolet light. Somewhere inside it, new stars are being born, some of which will never be seen by anything sentient. They'll burn, collapse, and disappear without ever being timed or remembered. And yet, their clocks still tick. You float back toward your console and open your logs. Your ship keeps time 3 ways now. Ship time, your personal aging, mission time, from launch, and Earth standard, which has already looped into the 80s CE. None of them agree. None of them ever will. You add a new entry. Time is not a river, it's a web. We tug one thread, and others vibrate. No center, no anchor, just motion and memory. You pause, then add, also, tea is overdue. You heat some water. The packet is still labeled green tea, though you're suspicious of the slightly purple tint. You sip. It's fine. Time is an illusion. Flavor probably is too. You wonder if anyone anywhere is sipping tea at this exact moment. You realize they're probably not. Because you're now, it's yours alone. The clock ticks, or doesn't. Either way, you keep drifting. How far is too far? There's a moment, halfway through prepping your next burn, when your finger hovers over the navigation console just a few seconds too long. Because the destination blinking back at you? It's not 5,000 years ahead, not 10,000. This time, it's 1,000,000. 1,000,000 years. Even your ship pauses to think about it. Systems chirp, process, then politely ask, confirm final destination. Earth, estimated arrival date, 1,002,846 CE. You don't answer right away. You sit back, floating in the stillness, tea cooling in your hand, and think, is this it? Is this the point where I stop being a traveler and start being a monument? Because at a certain point, time travel stops being exploration and starts being abandonment. You've skipped across tens of millennia already, enough to see language collapse, society rebuild itself 3 times, vending machines evolve into sentient mood interpreters. But 1,000,000? That's no longer the future. That's after the future has left the building. It's deep time, geological time, evolutionary time. The kind of scale where continents rearrange and the sun grows measurably hotter. The kind of future where even the word future feels like an ancient brand of toothpaste. You take a breath. The air here still tastes like lemon and recycled carbon, the only constants. You remember something from your training, back when you were still in meat space with other humans and sandwiches and weather. A projected timeline, a whiteboard scribbled with color-coded estimates. 10,000 CE, languages unrecognizable. 50,000 CE, artificial superintelligences, possible disembodiment. 100,000 CE, Physical infrastructure decays without constant renewal. 1 million CE. Homo sapiens? Possibly extinct. Possibly something else. The room laughed nervously. Someone asked if we'd still have movies. Someone else wondered if cats would still be cats. You wonder that too now. You lean back, hands behind your head, and realize this next jump, this enormous stretch, comes with no promise of reception. No guarantee that Earth will even be recognizable. Historians, the few that still studied linear time, used to ask the same question about how far was too far. Not in terms of travel, but in terms of meaning. At what point does the future become so far removed from your origin that your very presence is absurd? A language no one can decode, a relic no one remembers. Fringe note: one philosopher, can't remember her name but you loved her voice, once said, "The ultimate time traveler doesn't visit the future, they haunt it." That line stayed with you, haunted you a little, because that's the edge you're standing on now. You fire up the external sensors. Earth is a hazy blue crescent below, cloaked in clouds, quietly humming in the background of the cosmos. You check the long-range projections. If all goes well, your ship will slingshot around 2 pulsars, tap into a high-energy wake, and drift through unthinkable amounts of time with only the occasional status ping. You'll go into deep cryo. Not the old-fashioned freezing your nose hairs off kind, but a slower method. Cellular suspension. Your body will idle like a paused song. Your mind, though, it's not so easily stilled. What will you wake up to? A planet paved with silicon beings? A dry, scorched rock, empty and silent? A biosphere you can't survive? Or maybe nothing. Maybe your ship will circle endlessly until entropy pulls the curtain. And yet, you hover over the confirm button again. What compels you? It's not curiosity anymore. Not really. It's something smaller, stranger. A stubborn need to leave a footprint in the deepest snow. You think, if anyone ever finds me, if I land in a future that can't read me, can't even recognize me, what will I be? A story, a mistake, a myth? You tap the console. Begin message log, traveler log, final stretch. If you're receiving this, then I made it, or tried to. I've traveled through layers of time you can't imagine. I've seen Earth wear new faces, speak in harmonies, rewrite its own biology. I've been forgotten politely and remembered vaguely. And now I'm heading farther than I was ever meant to. I don't know what I expect, but I'm still hoping for someone to wave back, or at least wonder who I was. You pause, then add, "P.S. Please pet a cat for me if those still exist." You look out the viewport one more time. The stars don't twinkle out here. They shine like hard truths. And just before you hit confirm, a final thought occurs to you. You didn't survive this journey because you're strong, or smart, or lucky. You survived because you kept going. Past doubt, past silence, past the loss of meaning. You hit the button, engines warm, cryo protocols initiate, your eyelids grow heavy. The hum of the universe swells around you, not as sound, but as time, folding over your ship like a blanket. No dreams? Just drift. Into the deepest future, into forever. The ship is quiet now, not silent. There's always sound, if you listen closely. The low hum of the reactor, the whisper of coolant circulating through the walls, the occasional soft click of temperature regulators nudging your environment just a little closer to comfort. But everything else, the motion, the light, the pull of decision, has faded into stillness. You're in stasis. Floating, breathing so slowly, it doesn't even count as effort. Your heart slows to a rhythm older than language. Your thoughts no longer race, they meander, they stretch. Like fog curling over a field that hasn't been touched in centuries. Outside, the stars barely shift. Even light moves lazily now. Earth, whatever version remains, is gone from view, behind you, lost in memory, or maybe reshaped into something else entirely. The ship no longer logs it as a destination, only as a past coordinate. Something you passed through once, long ago. Your dreams, if they exist in this state, have taken on a different texture. They're not stories, not visions of what's next. They're more like echoes. The sound of your name whispered across decades, then centuries, then millennia, until even the whisper forgets who you were. And somehow that's okay, because now, at the edge of everything, there's a strange kind of peace. You're not waiting anymore. You're not chasing time or dodging its weight. You've stepped out of the line altogether, like exiting a bustling station and finding yourself alone on a quiet platform, the night stretching out in all directions, patient and star-speckled. There's nothing left to do, nothing to fix, nothing to reach for, just the long exhale of deep time. And you, drifting through it, light as breath, still, whole. This is what it feels like, in the end. To travel into the future, to outrun meaning, to fall into stillness and remain. Sleep well, traveler. You've gone far enough.